Question 1. A patient is prescribed infusion of 1 gram of vancomycin in 250 milliliters of D5W to run over 2 hours. The 4-tubing has a drop factor of 15 gtt/ml. What is the flow rate in drops per minute, gtt/min? A. 31 gtt/min. B. 63 gtt/min. C. 94 gtt/min. D. 125 gtt/min. Answer: A. 31 gtt/min. This question tests your ability to calculate 4 flow rates in drops per minute. The key is to first find the flow rate in ml per minute and then use the drop factor to convert to drops per minute. You need to infuse 250 milliliters over 2 hours, 120 minutes, which is 250 milliliters/120 minutes is approximately 2.083 milliliters per minute. Multiplying the ml/min rate by the drop factor, 15 gtt/ml, gives approximately 31.25 gtt/min, which rounds to 31 gtt/min. Always break down complex rate calculations into smaller, manageable steps like converting total time to minutes first. Question 2. You need to prepare 500 milliliters of a 0.9% sodium chloride solution using sterile water for injection and a 23.4% sodium chloride stock solution. How many ml of the 23.4% sodium chloride stock solution are needed? A. 1.92 milliliters. B. 10.26 milliliters. C. 19.23 milliliters. D. 21.05 milliliters. Answer: C. 19.23 milliliters. This problem requires a dilution calculation using the formula C1V1 equals C2V2, where C1 is the initial concentration, V1 is the initial volume, what you're solving for, C2 is the final concentration, and V2 is the final volume. You want to make 500 milliliters, V2, of a 0.9% solution, C2, using a 23.4% stock, C1. So, 23.4% asterisk V1 equals 0.9% asterisk 500 milliliters. Solving for V1 gives V1 equals 0.9% asterisk 500 milliliters, slash 23.4% equals 450 slash 23.4 is approximately 19.23 ml. Remember to keep your units consistent, percentages in this case, when using the dilution formula. Question 3. A patient weighing 150 pounds is prescribed drug X at a dose of 5 mg per kilogram per day divided into 3 equal doses. The medication is available as 250 mg tablets. How many tablets should the patient take per dose? A. 1 tablet. B. 2 tablets. C. 3 tablets. D. 4 tablets. Answer: A. 1 tablet. This question tests your ability to calculate a dose based on patient weight and then determine the number of tablets per dose. First, convert the patient's weight from pounds to kilograms by dividing by 2.2. 150 pounds/2.2 pounds per kilogram is approximately 68.18 kilograms. Next, calculate the total daily dose. 5 mg per kilogram per day asterisk 68.18 kilograms is approximately 340.9 mg per day. Since the total daily dose is divided into 3 equal doses, each dose is approximately 340.9 mg/3 is approximately 113.6 mg. Given the tablets are 250 mg each, taking 1 tablet, 250 mg, is the closest and most practical option that provides at least the required dose. Always ensure you are calculating the dose per administration after finding the total daily amount. Question 4. You receive a prescription for amoxicillin 250 mg per 5 milliliters, dispense 150 milliliters. Sig. 1 teaspoon POTID. How many days will this prescription last? A. 5 days. B. 7.5 days. C. 10 days. D. 15 days. Answer: C. 10 days. This question requires you to calculate the total daily dose and then determine the duration of the prescription supply. The prescription is for 1 teaspoon, TSP, by mouth, PO, 3 times a day, TID. Knowing that 1 teaspoon equals 5 milliliters, the patient takes 5 milliliters per dose. The total daily volume is 5 milliliters per dose * 3 doses/day equals 15 milliliters per day. You are dispensing a total volume of 150 milliliters. To find the number of days the supply will last, divide the total volume by the daily volume, 150 milliliters/15 milliliters per day equals 10 days. Pay close attention to unit conversions, like teaspoons to milliliters, as they are crucial steps in these calculations. Question 5. A pharmacist asks you to prepare 1 liter of a 1:5000 solution of potassium permanganate. The stock solution available is a 10% potassium permanganate solution. How many milliliters of the stock solution are needed? A. 0.2 milliliters. B. 0.5 milliliters. C. 2 milliliters. D. 5 milliliters. Answer: C. 2 milliliters. This problem involves converting a ratio strength to a percentage and then using the dilution formula. A 1:5000 solution means 1 gram of solute in 50 ml of solution. To convert this ratio strength to a percentage, find the grams in 100 milliliters. 1g/5000 milliliters equals xg/100 milliliters, so x equals 100 divided by 5000 is equal to 0.02 grams in 100 milliliters, which is a 0.02% solution. You want to make 1 liter, 1000 milliliters, of this 0.02% solution. C2 equals 0.02%, V2 equals 1000 ml, using a 10% stock. C1 equals 10%. Using C1V1 equals C2V2, 10% * V1 equals 0.02% * 1000 milliliters. Solving for V1 gives V1 equals 0.02% * 1000 milliliters, /10% equals 20/10 is equal to 2 ml. Always convert ratio strengths to percentages or mg/ml before using them in dilution calculations. Question 6. You have a vial containing 1 gram of a powdered drug. The manufacturer states that adding 2.5 milliliters of sterile water for injection will result in a solution with a concentration of 250 milligrams per milliliter. What is the powder volume, the volume occupied by the drug itself after adding the diluent? A. 1.5 milliliters. B. 2.5 milliliters. C. 3.5 milliliters. D. 4.0 milliliters. Answer: A. 1.5 milliliters. This question tests your understanding of powder volume and how it affects the final volume after reconstitution. You start with 1 gram of drug, which is 1000 milligrams. The final concentration after reconstitution is 250 milligrams per milliliter. To find the total final volume, divide the total amount of drug by the concentration, 1000 milligrams/250 milligrams per milliliter equals 4 milliliters. This final volume, for milliliters, is the sum of the added diluent volume, 2.5 milliliters, and the volume the powder itself occupies, powder volume. To find the powder volume, subtract the diluent volume from the final volume. For milliliters, final volume, 2.5 milliliters, diluent volume, equals 1.5 milliliters, powder volume. Remember that when reconstituting powders, The final volume is often greater than just the volume of added diluent because the powder takes up space. Question 7. A 70 kg patient is to receive gentamicin at a dose of 5 mg per kilogram for every 8 hours. Gentamicin is available as a 40 mg per milliliter solution in 2 ml vials. How many milliliters of the gentamicin solution are needed for a single dose? A. 3.5 milliliters. B. 5.25 milliliters. C. 8.75 milliliters. D. 10.5 milliliters. Answer: C. 8.75 milliliters. This calculation involves determining the individual dose based on weight and then finding the volume needed from the stock solution. First, calculate the dose for this 70 kg patient. 5 mg per kilogram * 70 kg equals 350 mg per dose. The available solution has a concentration of 40 mg per milliliter. To find the volume needed for a 350 mg dose, divide the required dose amount by the concentration. 350 mg / 40 mg per milliliter equals 8.75 milliliters. Always double-check that you are calculating a single dose when the prescription specifies administration frequency. Question 8. A pharmacy purchases a medication for $15 per bottle. The pharmacy applies a 30% markup on the cost price. What is the selling price of the medication? A. $19.50. B. $21.43. C. $22.50. D. $25. Answer: A. $19.50. This question tests your ability to calculate a markup on the cost price. The cost of the medication is $15. A 30% markup means the pharmacy adds 30% of the cost to determine the selling price. Calculate the markup amount. 30% of $15 equals 0.30 $15 equals $4.50. The selling price is the cost plus the markup. $15 plus $4.50 equals $19.50. Markup is always calculated as a percentage of the initial cost price. Question 9. You need to prepare 60 grams of a 2.5% hydrocortisone cream using a 1% hydrocortisone cream and a 5% hydrocortisone cream. How many grams of the 1% hydrocortisone cream are needed? A. 22.5 grams. B. 30 grams. C. 37.5 grams. D. 45 grams. Answer: C. 37.5 grams. This problem is a classic alligation problem used to find the proportions of two different concentrations needed to make a desired concentration. Set up an alligation grid with the two available concentrations, 1% and 5%, on the left and the desired concentration, 2.5%, in the center. Subtract diagonally. 5% to 2.5% equals 2.5 parts of the 1% cream needed, and 2.5% to 1% equals 1.5 parts of the 5% cream needed. The ratio of 1% cream to 5% cream is 2.5, 1.5, which simplifies to 5, 3. The total number of parts is 5 plus 3 is equal to 8. You need to make a total of 60 grams. The amount of 1% cream needed is 5 parts / 8 total parts, * 60 grams equals 5/8, * 60 is equal to 37.5 grams. Alligation helps determine the ratio of ingredients. You then use this ratio to find the actual amounts needed for the desired total quantity. Question 10. A prescription calls for administering 500 milliliters of D5W at a rate of 100 milliliters per hour. How many hours will the infusion take? A. 2.5 hours. B. 5 hours. C. 10 hours. D. 20 hours. Answer B. 5 hours. This is a straightforward flow rate calculation to determine the duration of an infusion. You have a total volume of 500 milliliters to infuse and the rate is 100 milliliters per hour. To find the duration, divide the total volume by the infusion rate, 500 milliliters / 100 milliliters per hour equals 5 hours. When dealing with infusion times, ensure your volume units, ml, and rate units, ml/hour, are compatible so the volume unit cancels out, leaving only the time unit. Question 11. You are asked to prepare 100 milliliters of a 1:200 solution. How many milligrams of the solute are needed? A. 5 milligrams. B. 50 milligrams. C. 500 milligrams. D. 5,000 milligrams. Answer C. 500 milligrams. This question requires converting a ratio strength to a weight in volume amount for a specific volume. A 1:200 solution means 1 gram of solute in 200 milliliters of solution. You need to find the amount of solute in 100 milliliters. Set up a proportion, 1 gram/200 milliliters equals x grams/100 milliliters. Solving for x gives x equals 1 gram * 100 milliliters / 200 milliliters equals 100/200 is equal to 0.5 grams. The question asks for milligrams, so convert grams to milligrams. 0.5 grams * 1000 milligrams per gram equals 500 milligrams. Remember that ratio strengths usually represent grams per milliliter unless specified otherwise, and always convert to the requested final unit. Question 12. A patient is prescribed medication Y 0.75 milligrams orally once daily. The medication is available in 0.5 milligrams tablets. How many tablets should the patient take per dose? A. 0.5 tablets. B. 1 tablet. C. 1.5 tablets. D. 2 tablets. Answer C. 1.5 tablets. This calculation involves determining the number of tablets needed to achieve the prescribed dose. The prescribed dose is 0.75 milligrams, and the available tablets contain 0.5 milligrams each. To find the number of tablets, divide the required dose amount by the amount per tablet, 0.75 milligrams / 0.5 milligrams per tablet equals 1.5 tablets. It is common in pharmacy calculations to determine that a partial tablet is needed for the correct dose. Question 13. How many grams of pure drug are in 250 milliliters of a 5% solution? A. 5 grams. B. 10 grams. C. 12.5 grams. D. 25 grams. Answer C. 12.5 grams. This question tests your understanding of percentage strength, weight/volume. A 5% solution means there are 5 grams of drug in every 100 milliliters of solution. You have 250 milliliters of this solution. To find the total grams of drug, set up a proportion, 5 grams/100 milliliters equals x grams/250 milliliters. Solving for x gives x equals 5 grams * 250 milliliters / 100 milliliters equals 1250 / 100 is equal to 12.5 grams. Percentage strength, with V, is a direct way to find the grams of solute in a given volume of solution. Question 14. You need to prepare 400 milliliters of a 30% solution by mixing a 20% solution and a 50% solution. Using alligation, how many ml of the 50% solution are needed? A. 100 milliliters. B. 133.3 milliliters. C. 200 milliliters. D. 266.7 milliliters. Answer B. 133.3 milliliters. This is another alligation problem, similar to question 9, but dealing with volumes of liquids. Set up the alligation grid with 20% and 50% on the left and 30% in the middle. Subtract diagonally, 50% to 30% equals 20 parts of the 20% solution, and 30% to 20% equals 10 parts of the 50% solution. The ratio of 20% solution to 50% solution is 20:10, which simplifies to 2:1. The total number of parts is 2 plus 1 is equal to 3. You need to make a total volume of 400 milliliters. The amount of 50% solution needed is 1 part/3 total parts, * 400 milliliters equals 1/3, * 400 is approximately 133.3 ml. Remember that the numbers on the right side of the alligation grid represent the parts of the solution listed opposite them on the left. Question 15. A bulk bottle contains 5 pounds of a powdered chemical. How many kilograms is this? A. 2.27 kilograms. B. 2.5 kilograms. C. 11 kilograms. D. 22.7 kilograms. Answer A. 2.27 kilograms. This question requires converting between the avoirdupois system, pounds, and the metric system, kilograms. You need to know the conversion factor between pounds and kilograms, which is approximately 1 kilogram equals 2.2 pounds. To convert 5 pounds to kilograms, divide the weight in pounds by the conversion factor. 5 pounds/2.2 pounds per kilogram is approximately 2.27 kilograms. Memorizing common conversion factors between different measurement systems is essential for pharmacy calculations. Question 16. A prescription is written for drug C 25 mg per square meter once daily for a patient with a body surface area, BSA, of 1.5 square meters. The drug is available in vials containing 50 mg in 10 milliliters. How many milliliters should be administered per dose? A. 5 milliliters. B. 7.5 milliliters. C. 10 milliliters. D. 12.5 milliliters. Answer B. 7.5 milliliters. This problem involves calculating a dose based on body surface area, BSA, and then determining the volume from a stock solution. First, calculate the total dose for this patient, 25 mg per square meter * 1.5 square meters equals 37.5 mg. The available drug concentration is 50 mg in 10 milliliters. To find the volume needed for a 37.5 mg dose, set up a proportion, 50 mg/10 milliliters equals 37.5 mg/x ml. Solving for x gives x equals 37.5 mg * 10 milliliters / 50 mg equals 375 / 50 is equal to 7.5 ml. Dosage calculations based on BSA require you to first calculate the patient's total dose before finding the volume. Question 17. An ointment base costs $8 per pound. How much does 100 grams of this base cost? A. 80 cents. B. $1.76. C. $8. D. $17.60. Answer B. $1.76. This question requires converting between units and then calculating cost based on weight. The cost is given per pound, and you need the cost for 100 grams. First, convert 1 pound to grams. 1 pound is approximately 454 grams. So, the ointment base costs $8 for 454 grams. To find the cost per gram, Divide the cost by the number of grams. $8/454 grams is approximately $0.0176 per gram. Finally, multiply the cost per gram by the desired weight. $0.0176 per gram * 100 grams is approximately $1.76. Breaking down cost calculations involving different units into a cost per unit amount is a useful strategy. Question 18. You receive a prescription for a topical solution that requires 100 mg of drug A in a total volume of 20 milliliters. What is the percentage strength, with V, of drug A in the solution? A. 0.05%. B. 0.5%. C. 5%. D. 50%. Answer: B. 0.5%. This problem tests your ability to calculate percentage strength, weight/volume, from the amount of solute and the total volume. Percentage strength, with V, is defined as grams of solute per 100 milliliters of solution. You have 100 milligrams of drug A, which needs to be converted to grams. 100 milligrams equals 0.1 grams. The total volume is 20 milliliters. To find the grams per 100 milliliters, set up a proportion. 0.1 grams/20 milliliters equals x grams/100 milliliters. Solving for x gives x equals 0.1 grams * 100 milliliters /20 milliliters equals 10/20 is equal to 0.5 grams. Since percentage strength is grams per 100 milliliters, the strength is 0.5%. Ensure your weight is in grams and your volume is in milliliters when calculating, with V, percentage strength. Question 19. An 4 infusion of 1 liter of NS, normal saline, is ordered to run at 80 milliliters per hour. How many hours will this infusion take to complete? A. 8 hours. B. 10 hours. C. 12.5 hours. D. 125 hours. Answer: C. 12.5 hours. This is another calculation of infusion duration, similar to question 10, but requiring a unit conversion first. The total volume to infuse is 1 liter, which needs to be converted to milliliters. 1 liter equals 1,000 milliliters. The infusion rate is 80 milliliters per hour. To find the duration, divide the total volume by the rate. 1,000 milliliters/80 milliliters per hour equals 12.5 hours. Always ensure the units for the total volume and the rate's volume component are the same before performing the calculation. Question 20. You need to prepare 50 milliliters of a 15% solution from a 60% stock solution. How much diluent, e.g., sterile water, is needed? A. 12.5 milliliters. B. 25 milliliters. C. 37.5 milliliters. D. 45 milliliters. Answer: C. 37.5 milliliters. This problem uses the dilution formula, C1V1 equals C2V2, to find the amount of stock solution needed, and then asks for the amount of diluent. You want to make 50 milliliters, V2, of a 15% solution, C2, using a 60% stock, C1. Using C1V1 equals C2V2, 60% * V1 equals 15% * 50 milliliters. Solving for V1 gives V1 equals 15% * 50 milliliters /60% equals 750/60 is equal to 12.5 ml. This is the volume of the 60% stock solution needed. To find the amount of diluent, subtract the volume of the stock solution from the final desired volume, 50 milliliters, final volume, 12.5 milliliters, stock volume, equals 37.5 milliliters, diluent volume. Dilution problems often have a second step asking for the diluent volume, so read the question carefully. Question 21. A drug is available as capsules containing 1/4 grain. How many milligrams of the drug are in each capsule? A. 15 milligrams. B. 16.2 milligrams. C. 30 milligrams. D. 32.4 milligrams. Answer: B. 16.2 milligrams. This question requires converting from the apothecary system, grains, to the metric system, milligrams. You need to know the conversion factor between grains and milligrams, which is approximately 1 grain is approximately 64.8 milligrams. The capsule contains 1/4 grain. To convert this to milligrams, multiply the amount in grains by the conversion factor. 1/4 grain asterisk 64.8 milligrams per grain is equal to 0.25 by 64.8 milligrams equals 16.2 milligrams. Memorizing the apothecary to metric conversion for grains is vital for historical dosage forms. Question 22. An order is for medication A 5 milligrams per kilogram per day divided Q 6 hours for a patient weighing 88 pounds. The medication is available as an oral suspension containing 25 milligrams per 5 milliliters. How many ml should the patient take per dose? A. 4 milliliters. B. 8 milliliters. C. 10 milliliters. D. 16 milliliters. Answer: C. 10 milliliters. This problem requires calculating a dose based on patient weight, determining the dose frequency, and then finding the volume from the available suspension. First, convert the patient's weight from pounds to kilograms. 88 pounds / 2.2 pounds per kilogram equals 40 kilograms. Calculate the total daily dose. 5 milligrams per kilogram per day asterisk 40 kilograms equals 200 milligrams per day. The order is divided every 6 hours, Q 6 hours, which means 4 doses per day, 24 hours / 6 hours per dose. The amount of medication per dose is 200 milligrams per day / 4 doses / day equals 50 milligrams per dose. The oral suspension contains 25 milligrams in 5 milliliters. To find the volume needed for a 50 milligrams dose, use a ratio, 50 milligrams / 25 milligrams, asterisk 5 milliliters equals 2 by 5 milliliters equals 10 milliliters. Always calculate the dose per administration after determining the total daily dose and the number of doses per day. Question 23. A patient is receiving a dopamine infusion at a rate of 5 micrograms per kilogram per minute. The patient weighs 132 pounds. The 4-bag contains 400 milligrams of dopamine in 250 milliliters of D5W. What is the infusion rate in ml/hour? A. 10 milliliters per hour. B. 11.25 milliliters per hour. C. 20 milliliters per hour. D. 22.5 milliliters per hour. Answer: B. 11.25 milliliters per hour. This is a complex 4-rate calculation requiring several conversions. First, convert the patient's weight to kilograms. 132 pounds / 2.2 pounds per kilogram equals 60 kilograms. Calculate the dose rate in mcg per minute. 5 micrograms per kilogram per minute asterisk 60 kilograms equals 300 micrograms per minute. Convert the concentration of the 4-bag to mcg/ml. 400 milligrams equals 400,000 micrograms. The concentration is 400,000 micrograms / 250 milliliters equals 1,600 micrograms per milliliter. To find the volume rate in ml/min, divide the dose rate, mcg/min, by the concentration, mcg/ml. 300 micrograms per minute / 1,600 micrograms per milliliter is approximately 0.1875 milliliters per minute. Finally, convert ml/min to ml/hour. 0.1875 milliliters per minute asterisk 60 minutes per hour equals 11.25 milliliters per hour. Breaking down complex unit conversions step by step is key to solving these problems accurately. Question 24. A pharmacy wants to make a 15% W/W ointment. They have 50 grams of a 20% W/W ointment and need to use a petrolatum base, 0% drug. How many grams of the petrolatum base are needed? A. 16.67 grams. B. 25 grams. C. 33.33 grams. D. 50 grams. Answer: A. 16.67 grams. This problem uses alligation with weights, W/W, to find the amount of base needed. You are mixing a 20% ointment and a 0% base to get a 15% ointment. Set up the alligation grid, 20% and 0% on the left, 15% in the middle. Subtract diagonally, 15% to 0% equals 15 parts of the 20% ointment, and 20% to 15% equals 5 parts of the 0% base. The ratio of 20% ointment to 0% base is 15:5, which simplifies to 3:1. You have 50 grams of the 20% ointment, which represents 3 parts. To find the weight of one part, divide the weight by the number of parts. 50 grams/3 parts is approximately 16.67 grams per part. The amount of petrolatum base needed is 1 part, so you need approximately 16.67 grams. Alligation works for weight-in-weight percentages too. The resulting ratio applies to the weights of the components. Question 25. A prescription for eye drops is written for instill 2 drops in each eye twice daily. The bottle contains 10 milliliters. Assuming there are 20 drops per ml, how many days will the bottle last? A. 12.5 days. B. 25 days. C. 50 days. D. 100 days. Answer: B. 25 days. This problem requires calculating the total daily volume used and then determining the day's supply. The patient uses 2 drops in each eye, and there are 2 eyes, so that's 2 drops/eye*2 eyes equals 4 drops per administration. The drops are used twice daily, so the total daily use is 4 drops/administration*2 administrations/day equals 8 drops per day. The bottle contains 10 milliliters, and there are 20 drops per ml. The total number of drops in the bottle is 10 milliliters*20 drops/ml equals 200 drops. To find the number of days the bottle will last, divide the total drops by the daily drops used. 200 drops/8 drops/day equals 25 days. When calculating days supply for drops, convert the total volume to the total number of drops first.